something, I don't know if I'd really call it a property or anything formal. It's just kind of common sense. If I told you that I had the log base 6 of x over here, and I told you it equaled the log base 6 of 10, doesn't it make common sense to you? What does x have to equal for that to be true? If these are both log base 6, and I'm telling you they're equal, what would x have to be true? So what our goal is today is we're trying to get both sides written as a single logarithm, so we can essentially drop the logarithm out and just figure out what the x or the x expression is going to be. And we're going to use our properties of condensing to do that. Okay, so our very first thing, blurry here. There we go. Our very first thing is, I noticed to the right, isn't this already written as a single logarithm? So I'm not going to do anything on that right side. On the left side, though, we can use some of our properties from yesterday to combine. All right, would you try that, please? Would you try to combine this side? Okay, once you do that, would you check with your partner and see if you guys both got the same thing? This is subtraction, so hopefully you wrote that as a quotient or division. And this 2 used to be there. So on the top of my fraction, do you have an x squared? Good. And then divided by, there's no exponent in front of that one, so that would just be a 4 on that side. Are we good? Okay. On the other side, I said we weren't touching that. That's just log base 3 of 25. So once we condense the logarithms, so now I have that scenario that I talked about a minute ago. As long as I satisfy the domain of log, and the deal with the logarithm is it can never be negative. Okay, so we'll talk about that in a second. We're going to take off the negative. I can drop that logarithm out. So in order for this to be true, I now know that x squared over 4 has to equal 25. And we have learned how to solve that already. So the first thing I'm going to do is I'm going to get rid of the divided by 4. What am I going to do to undo divided by 4? Multiplication. So we're going to multiply both sides by 4. Okay. And then we are left with x squared equals, what's 25 times 4? 100. All right, what am I going to do now? How do I undo x squared? Take the square root of both sides. Now this is where, I'm going to talk about this in a second, but we're going to have to check and make sure that the expression up here is positive when we're done, but I think it will be. We have to add a plus or minus. Remember when we did that last semester? Okay. So x equals, and what is the square root of 100? 10. So there are two solutions to this. They are plus or minus 10. And we just want to double check. When we put them back in for x, do they make this expression positive? Both of them do, because what happens when you square negative 10? It still turns into a positive. Okay? So then this would be my solution to that. All right, so let's now try one with division. All right, so I did division, sorry, I misspoke. Let's try one with multiplication. So for this one, I'm going to have you condense it a minute. So go ahead and try that. It's addition. Would you condense it as one log? And when you're done condensing it, check with somebody around you, see if you get the same thing. So for this, I see we have log base 2. Oh, I made a mistake here, guys. Hold on. In my notes. We'll put it together in a second, but I think I have to fix something. Log base 2 of, did you have x times x plus 2? And this should be, would you fix that and make it log base 2 of 3? Some typos there. Those should all be log base 2s. Would you change that and make sure it's log base 2 of 3? Okay, same deal as before. Since I have them written as log base 2 on both sides, I am now going to drop the logarithm expression out. So I have x times x plus 2 equals 3. And now we're going to go ahead and solve. So I need to distribute first. When I distribute, what do we have here? X squared plus 2x, right, equals 3. Uh-oh. You can't just take the square root of this guy. How do we solve that? What are our ways? Oh, good. Either factoring, this one's factorable, or quadratic formula. Some of you really don't like factoring, so you're always using quadratic formula, which is fine. It just, sometimes a factoring would take a little less time. So, what do we got to do either of those things, though? I have to move the 3 to the other side. Okay. So if you're going to run it through quad formula, a reminder here, I'll write the quad formula below. X equals negative b, plus or minus square root, b squared minus 4ac, all over 2a. Go for it, okay? But I'm going to go ahead and factor this. I think that's a skill we can always work on. Let's write our 2 parentheses. Okay. This is an x and an x. So what we're looking for here is something that multiplies to be negative 3, but the outers and inners add up to be 2. What do you think? Multiplies to be negative 3, outers and inners add up to be 2. X minus 1, x plus 3. Okay, what do I do next? Set them both equal to 0. So if x minus 1 would equal 0, x would equal 1. That's one of my solutions. Oh, in a second I'm going to double check and make sure that it works in the original. This would be x plus 3 equals 0, so x equals negative 3. Okay. So there's an issue with that x equals negative 3 though. If I put 1 in here, we just want to make sure the logarithm has to be positive. You can only take the logarithm of positive numbers. Okay? 1 would make both of these positive. Agreed? Would negative 3 make these positive? No. So just like some other times in this class, that's an extraneous solution. We're going to cross that one out. Okay. Are there any questions that you have?